So today we are going to discuss about carry skip adder. Okay. So this is the last adder which we are going to discuss. So before starting this class, I will do a quick revision of what is a carry select adder and carry look ahead adder. Okay. So what was we had something called ripple carry adder, right? So what was the ripple carry adder doing? So it was like connecting all adders in series, and it was waiting every other adders to generate carry out, and that will be passed to another adder, right? So this was the flow that was going inside the ripple carry adder, and it usually waits for every steps to complete to you get your final carry. So so the problem is in the ripple carry adder is that it's very slow, right? So coming to carry look ahead adder. Okay. So what was the carry look ahead adder doing? It was like it's predicting carry, like it's what it used to predict carry, right? So how it's going to predict? By using something called as generate and propagate signal, right? So using generate and propagate signal, the carry look ahead adder used to predict the carry, right? In that, it was working like in the form of parallel, right? It's like it didn't depend upon other adders to generate the carry. It was something like using propagate and generate signal. We got on the formula. Using that formula, it was going to like predict what the carry will be, right? So so what is the problem inside that carry look ahead adder? The problem we faced inside the carry look ahead adder is like we need to use more gates, and it takes more area, right? So why more gates? Because doing that kind of predicting values formulas, and using generate and propagate signal. Okay, in generate and propagate signal we are going to use gates, right? Like AND gate, OR gate, like that, XOR gate. So that things, when you are building for somewhat bigger you carry select adder, the complexity of that design and gate will be become more, right? So because of that, it was that one disadvantage thing that carry select adder had, sorry, carry look ahead adder had. So to clear that, we had gone through carry select adder, right? So what was we are going to do in carry select adder? Like it was going to compute both possibilities, right? So like it used to divide input bits into upper and lower input bits, and after dividing, it was going to think the possibilities. What will be the possibility of lower hardware, lower bits generating 0 and 1? Basis on that, we used to calculate what will be our final carry, right? So this is what we are going to learn till now, right? So coming to carry skip adder. Carry skip adder is nothing but like the name only suggests what it's going to do. What is the it's going to usually going to skip the carry. Okay, so as the name suggests, it's going to skip the carry. Just remember this one word. Okay, so what does the carry skip adder does? It's going to skip the carry. Like instead of predicting carry or computing both results, it asks you if you are going to build that design for carry skip adder, then using carry skip adder is nothing but like the code is asking, the design is asking you guys that can I skip the carry? like it's going to ask like that. Okay, so in today's class we are going to learn about so the goal of CSKA is simple. We know ripple carry adder is slow because carry passes through every full adder, whereas CLA predicts carries. CSLA computes both possibilities, whereas in CSKA uses a different approach. Okay, instead of calculating more carries, it tries to bypass them. Okay, so just remember the word skip to think a better and good example, like in a real time problem, right? Just think you are driving through a city. Okay, so while you are driving there will be signals on the road, right? Like you need to pass signal 1, signal 2, signal 3 to reach some destination. So in that kind of situation, like you usually use, like if the traffic is more, then you usually stop at every signal, right? So think this, now your this situation as RCA. Okay, so like a ripple carrier. So if you are going to stop at every signal because of traffic, then this is a good example for RCA, ripple carrier. Why? Because ripple carrier waits for the previous carry in. Okay, so the adder's previous carry in, it like it waits for that, and then that carry out is taken as carry in for the next adder. Okay, so now think you have a flyover. Okay, so you have two roads. Okay, one road, like you need like there are approximately 3 or 4 signals. You need to stop at each and every signal, and there is another road which has flyover. Okay, it's like a flyover road. So what happens in flyover, like it doesn't have any signals, right? So you can easily and travel from your destination to like what your destination you need to be reached, right? So this flyover road is nothing but this carry select skip adder. Okay, so I think everyone got the point, like why it's called as carry skip adder, because it doesn't wait for any carry, and like it will ask, can I skip the carry? Okay, so the best example is that flyover road. Okay, so if you are going to ask like when can a carry pass through a bit, right? So if you like have some this kind of doubt means, just remember it's going to pass the carry when the boat bit propagates carry. Okay, like when a bit propagates a carry, then it's going to pass that carry. Okay, so as like we already know the propagate formula, right? So what is the propagate formula that we have learned? This one, right? P is equal to A XOR B, right? So this is the formula. So when is the carry is going to skip or bypassed? The carry is going to bypass when you a bit generate a propagate. Okay, so when will be the propagate carry signal is generated? When any one of the input is one, like only one input should be one at a time. Okay, so then only the bit can propagate. So in that time it's going to skip the carry. Okay, so yeah, for carrying that propagate, both the input should be like same. Okay, if you have both input as 0 0 or 1 1, then it doesn't skip the carry. Okay, so if the both inputs are like interchange, like if a is 1 and b is 0 and b is 1 or a is 0, in that time it will skip the carry. Okay, so like if you are discussing about this concept means eventually you will get some doubts, right? So if every stage can pass carry, then why should we stop at every full ladder, right? So this will come to everyone's mind, like when you are going to read study these concepts. Okay, so just like why we need to stop at every full ladder if every carry is going to pass. So the thing is we shouldn't stop in every full ladder. Okay, so it's nothing but it will directly jump, and like this is the skip idea. Okay, so it will directly jump from one first adder to last adder. Okay, so if every full adder is generating a carry, sorry, propagating a carry, then it will directly jump from first adder to last adder. Okay, so this is the concept that's going to use inside the CSK. Yeah, just as I said, see here, this is carry generated by first adder, second adder, third adder, fourth adder. It's like if every adder is propagating a carry, then you can directly skip that. Okay, so this is how it's going to also. Okay, and there is one formula also like called as p group. Okay, so this is nothing but it will check what's the propagate value of each adder. Okay, just like p0, p1, p2 and p3, p are the propagate values of adder 1, adder 2, adder 3 and adder 4. Okay, so this is nothing but and gate when that and gate generates output as 1, when every adder is generating propagate as 1, right? When all your propagate signal is 1, then only the adder is going to work, right? So this is what, like, how to calculate propagate, and how to know that this propagating generated by this adder, like that. Okay, so based on this propagate value generated by particular adder, it will create an equation called p group. P group is nothing but propagate group. Okay, so like it will create a group of every propagate that had been calculated from adders, and based on that propagate value, it's going to define its final propagate, and then it tells like, yeah, I have got my propagate value is 1, so I can skip. Okay, so when you don't get your value as 1, then it's tell like, yeah, I need to like do function task the task normally. Okay, so how does it going to perform normally, like same in ripple carrier. Okay, it like the propagate is going to check if 1, then this will be bypassed, and at the point, think you have 4 adders. Okay, now like first adder is having propagate signal 1, second also 1, and third also 2, sorry, 0, and fourth one also 1. Okay, so now you will get p group as 0. Why? Because your third adder is generating propagate as 0, right? So what will you get when you have an and gate inside your equation? It only defines the value when all your propagate values are 1, right? But now your p2 is 0. So what does this do? Like it tells that I have got propagate group as 0. So I'm going to perform normally. Okay, like it will skip F0, FA0, FA1, and it will stop at this particular, only at this particular, and then it will check for propagate, and after that the value is skipped. Okay, that this is how you are going to achieve CSK. So just this is a flow diagram. Like if your propagate group is 0, then it will follow this path, or else this path. Okay, it will usually skip like directly from here. So this is how you're going to achieve CSKA. Okay, and this is nothing but Verilog implementation. Okay, so this is nothing but like you're going to create a module. Based on that module only, you're going to mention the ports that have been used inside that. How is this one? And also you're going to define like what are the things that you're going to achieve. Okay, so when coming to the CSKA, we usually do two types of tasks, right? Like one uh, is like skipping, and another one is like normal. Okay, so you need to write assign statement for both normal and other. Okay, so for that you also we need to calculate assign, right? Sorry, propagate, right? So you need to do that propagate also. And after propagate, if you get 0, right? If you like, you have two ways. If you get propagate as 0, then it should follow like normal. Okay, like this. Normal means is nothing but how you used to do inside a ripple carry, right? So that this is how you're going to achieve the second path. Okay, like normal path. Then after that, this is nothing but like what will be your final sum. Okay, like you are getting some bits, right? The usually our input want to be one bit, right? So usually our inputs will vary from like 16 bits, 32 bits, 64 bits, like that. We will have our input. So what it's going to do, it's going to like calculate each and every propagate value, and it will calculate a carry out of each and every adder, and that adder is finally summed to like the usual original bits. Okay, like think if you are giving input as 4 bits, then at last you need to have output as 4 bits. Okay, so this is what it's going to do, this equation. And this is set statement is nothing but it's checking whether your every propagate values is 1 or 0. Okay, so if any one of the like what is this symbol defined, this is nothing but AND gate, right? So it's check whether your all your AND gate propagate are getting zeros or 1. If any one of them is 0, then it's give p group as 0. Okay, so and the last step is nothing but assign. Okay, so we are using ternary operator. Okay, so what it's going to do, like it's check p group. Okay, if p group is true, then it will directly calculate scene. Okay, or else normal. Okay, that is how you're going to work in ternary operator, right? So after that, end module, and this is nothing but for 16 bits. Okay, so I have tried like I'm going to give you a task for you guys to create a 16-bit CSK, like how it's going to work. Okay, so and this is nothing but test bench. Just it's nothing but like creating a module and importing that module, and putting that module inside a unit under test method, and after that you are initially beginning that module, and the dump file and dump where is nothing but calculating the, sorry, to view the EP wave, right? So like to check whether our input signal is moving correctly in a waveform. Okay, so this is what the dump file and dump where does. And also you're going to like check the case. Okay, like if the group is one, so I have just written to understand. Okay, so what happens when your p group is 1 and p group is 0? Okay, so it's going to like, if p group is 1, then it will skip, or else it's going to do normal operation, right? So that is what it's going to do. So as usually, like I said, how the skip scenarios works is nothing but it will calculate p group. If p group is 1, then directly we skip the values, or else like it will perform normal ripple carry path. Okay, so this is how it's going to do. So, and these are the best case, worst case as scenarios for this CSKY. So for RC ripple carry adder, it will be like there will be like this is the comparison of like every adders we have learned so far, like ripple carry adder, ripple skip adder, sorry, carry skip adder, carry select adder, and carry look add adder. Okay, so like what will be the best case? Our ripple carry adder means nothing but it will like it will stop at every adders, right? So delays will be more, so that will be the best case, and that is also the worst case. Why? Because it doesn't have any option, like it will you need to calculate at every stages, right? So whether it's best or worst, it will follow the same path. Okay, we're coming to carry skip adder. Best case will be like 4 full adders and 4 mux. Okay, I did not explain why we are going to use sorry, multiplexer inside that. Okay, so just find out like why we need that multiplier in that design. Okay, like if I say everything, then like you guys won't put time into the this kind of things, and like you never going to know, like you will easily forget. Okay, so just do a small research on why we are going to use mux there, and if you didn't get, then I will explain the next lesson. Okay, so this will be the best case, like it will check for propagate of every adders, and if the group propagate is 1, like from one first full adder only, it's going to send the carry value to the multiplexer. It's nothing but like it's skipping every other adders, right? So that will be the best case. Worst case, like it will follow the same ripple carry adder, right? Like if you don't get a p group is 1, then it will follow this only. Okay, so average case is nothing but like inside I explained one something like if what happens if the third adder is generating propagate as 0, then it will do skip for first second, and it will stop at the third, and there will be like normal, right? So that is how it's going to do. So that's why average case means like out of 16 it may be like around 10 or 8% of your carry will be like need to calculate, and others have been already one, right? So based on that, it's going to work. By coming to carry select adder, this is also 4 FA and 1 mux. Okay, so why? Because you are going to divide for 4 bit, you're going to, sorry, 8 bit, you're going to divide that everything, and after that you need like upper bit. Okay, you after upper bit dividing your upper bit and lower bit, for upper bit Now we have 8 bit, right? So why only four full adder? Four full adder means what is the thing we are going to achieve in carry select adder? We are going to divide into bits, right? Like upper 4 bits, lower 4 bits. So only that's why you only have 4 ladders. Like 4 full adder means it takes from that. Okay, 4 full adder. Why 4 full adder? Because we are going to divide into 4 upper bits and 4 lower bits, right? So the main thing is it will internally calculate the lower bits. Like usually it like it predicts positive, checking the possibility whether it will maybe 0 or 1. Like if it's 0, then the upper 4 bits will be like values will be this, or else like that, right? So vice versa, it's like a working. So it's only using 4 full adder. And so just I said, right, why you are going to use mux there. And a carry select look ahead adder means best case means 4 levels. Like how it's going to work? Like it's calculated from equations, right? So that's why 4 level. 4 level is nothing but look here, 16 bit, right? Then 16 bit means it adds around 16 adders, right? So it divides into levels. Okay, like first 4 adders will be doing like this, and second, next, like that. It calculates every bit, and after that it will sum that bit, and you will get the output. Okay, so this is why we are using carry skip adder. Okay, to skip the procedure and keep it fast. Okay, like if you are designing something that should be fast, right? And it should use lesser area. So that's why we invented like carry skip adder. Okay, so I hope everyone got my point. And this is just summary like what we learned inside the CSKA, like propagate group or P group, power efficiency, and bypass mechanism, like very log reduction. Like everyone learned this, right? Why? What the I think everyone know this just because I explained right inside the very log code. Look here, I have mentioned something like to calculating P group. I have mentioned something like and P, right? So this is nothing but it's just a like short form of writing like and P0 and of P1 and of P2 and of P3. Just writing the short form. Okay. So this is nothing but it's going to take every P and it's going to apply and get for that. Okay. So this is what it's internally doing. So this is only this means nothing but like it's going to reduce that code into single line. Okay, so that is what called a variable reduction. Okay, and variable delay, just I said, right? It's going to like best case scenarios, your carry will be skipped from first item only, right? So I hope everyone got my point. Okay, so from tomorrow class we are going to start another concept other than the adder. So I think everyone got my point about carry select adder. Okay, so that's it for this class, guys.